Wonderful day to you all on this beautiful Monday, on this awesome Monday. Welcome to Yebo Tutor. Today we'll be doing functions. So as we are doing functions, I want everyone to be able to listen attentively and be able to cooperate with us. Please do comment so that we can engage together. Okay. Thank you so much for tuning in. My name is Vuyani and I'll be taking you for maths. Now, if it's your first time to tune in, please don't forget to subscribe on the YouTube channel, also to like our content and also to share to friends and family. Okay, now let's start with our class today. We'll be doing functions for grade 12. Okay. So they'll be doing functions on the grade 12 part. So if you check on Yebo Tutor, when you check and click for videos which are available on Yebo Tutor, there are things which are so essential that you have to check. There is a video on when we talked about functions as well. We did functions on grade 11 part. So now I'm gonna do the grade 12 part. I would really advise you that please do watch that video of functions on the grade 11 part which we did, which is available in the video section on Yebo Tutor card. Now let me just summarize first things first for you. Okay, so now on that video I had and explained that we have four types of graphs, or four different graphs which we plot in graphs and functions. So now the first one, we said we have straight line. We have a straight line graph which we were taught in grade 10, that is mx plus c. Grade 10, grade 8, grade 9. Then number 2, we have what we call a parabola, which is in this shape or in this shape. It's either smiling or it's angry. It's smiling or angry. And this parabola we were taught in grade 11, and we were taught that y is always equal to ax squared plus bx plus c. Y is the same as f of x. The function of x is equivalent to ax squared plus bx plus c. This is just an overview for what you and I would really advise you to check on the platform. Okay, then the last part which I want us to check on is the part which we clarified and last time on that video, that we have three forms. We have the standard form, the turning point form, as well as the intercept form on the parabola. So we also say that f of x can be equal to a x plus x minus p squared plus q, and we also said we have also f of x is equal to a x minus x1 and x minus x2. So this one now is a parabola which has three different formulas. F of x is equal to x squared plus bx plus c, and also f of x is equal to a x minus p all squared plus q. This is called the turning point formula. In other words, we are having the turning point coordinates which we'll be able to insert and be able to plot our function. And we also have the X-Intercept formula, which is the last one, which you're seeing, which I just circled right now. That's whereby now we are only given X-Intercept of our graph balls. Bear in mind that our function is always in this form, and we know that in order for us to plot our function, we plot on the XY axis. So it will be in this kind of form, or it will be in this form. And bear in mind that when it's having this shape or any either shape, it also have a turning point. This is what the turning point is the point in which the graph changes its shapes. So bear in mind that this turning point is calculated in different ways. So in order for you to get the x coordinate of the turning point, you must know that x is equal to negative b over 2a. So bear in mind that we say that this is our standard formula of parabola function. So now this is the value of b, this is value of a, so we just substitute them on this. And also this formula of calculating the turning point is also the same as the axis of symmetry of a parabola. So they usually love to ask in your exam that determine the axis of symmetry of this function. So the moment you see that this function is a parabola, don't worry about many things. Just use this formula that x is equal to negative b over 2a, because on this power on this x value, that's where you see this graph is equivalently, or is divided into two equal halves. So that's the axis of symmetry. Then after you have calculated the x value using this formula, you can now substitute your x value into the original function equation which you are given, so that you can be able to determine the y value of the TP, so that at the end you have your turning point, which is x is to y. But also I can give you this nice formula to calculate the value of y without substituting the x value, which says that y is equal to 4ac minus b squared over 4a. So if you use this equation, you'll also be able to determine the y value of the turning point. So that was my parabola, and I explained that. Now also we have what we call a hyperbola. This is grade 11 work. So also on hyperbola, we say that there is what we call the asymptotes, which are distinguished into two. We have the horizontal asymptote as well as the vertical asymptote. So bear in mind that the function is in the form of f of x is equal to a over x minus p plus q, where the value of of p and the value of q are the one which determines our asymptote. So x is equal to p always. This is the vertical asymptote. This is the vertical asymptote, and y is always equal to q. So bear in mind that we have x is minus p, but we are ending up having the vertical asymptote, which is x is equal to p. So someone will ask me, where is this x equal to p equivalent to? So if you are given this kind of scenario in your question, don't worry, just take what you are given here at below. If it's x minus 2, you take it as it is and equate it to 0. Then you make x the subject of the formula. So in this case it will be x minus 2, but in this case now on our equation of a hyperbola, we know that x minus p, then we substitute it to 0, then we make x the subject of the formula, and now we see that x is equivalent to p. So when they ask you to determine the vertical asymptote, that's where you just take this part of your equation and substitute in your original and substitute and equate it to equivalent to 0. Then y is equal to q. This is the horizontal asymptote. So this is just refreshing your memory on grade 11 work. So now I just want to also highlight something. for you so that you can understand. I just want to also highlight something for you so that you can understand. Something just happened. Just give me 2 minutes to fix that technical issue, please. I would really love to apologize for that small technical issue which just happened right now. Please really do forgive me for that technical issue which just happened right now. It's just a small technical issue, but we have fixed that right now. We just have fixed that right now. Okay, let's proceed. Now, I was still on the hyperbola. Okay, I was on the hyperbola now. So now I want us to just finish, and the axis of symmetry of the hyperbola is x is equal it's y is equal to x minus p plus q, or y is equal to negative x minus p plus q. So it depends. Let me just use this one, x plus. So this is when you are given a graph f of x, which is equal to a over x plus p plus q. So it will be your axis of symmetry will be y is equal to x plus p plus q. So it will be just like this, or the negative x-axis, the negative axis of symmetry, it will be negative x plus p times q. Right. Now let's move forward. Yes, let's move forward. So as we are here now, I also spoke about the exponential function, and we say that the exponential function is a function which is in the form of f of x is equal to a times b x plus p plus q. Okay, where y is equal to q is the only horizontal asymptote of the graph. So now in grade 12, this was just a quick summary about grade 11 work. Now in grade 12, what is important and what you are supposed to know is the inverses of graphs. So in grade 12 now, we are looking on what happens when you determine the inverse of a graph. So in order for us to determine the inverse of a graph, I want us to know and understand few things. That, for instance, let me just make an example. Determining the inverse of a graph. This is our graph, and maybe we have a straight line graph which is going across like this, and maybe this point is point -1 is to 0. Then this point, maybe it's point 3 is to 4. Okay, so that point, let me just write it here. So we have 3, 2, 1, 4, 1, 2, 2, 3, and 4. -1, -2, -3, -4. So this point I'm saying is 3 is to 4. So now this is your function. Okay, so in order for you to determine the inverse, we are just swapping. If your x, we are just swapping the x, y coordinate. So if it was 1 is to 0, now when you write or determine or want to plot an inverse of this function, it will be now 0 is to 1. If it's 2 is to 3, then when you're writing the inverse, it's now 3 is to 2. So that's how you determine the inverse of a function. So now, since we know how to determine the inverse of a function, let me just try to plot the inverse of this function. So if they ask us to plot the inverse of this function on the same axis, let me just try to use a different pen. So we know that we have our axis of symmetry. Okay, then now this one was -1 is to 0. So now on this new inverse function is now 0 is to -1. So here is 0 and here is -1. So we have a point here. This was 3 is to 4. Now it will be 4 is to 3. So where is our 4? Here is our 4. Where is 3? Here is 3. Then we have another point here. So this is now our new graph. Okay, this is now our new graph. So that's how easy it is to determine the inverse of a function. Right. Now, also what is important here is let me just do a parabola. We are given a parabola in this form, in this format, and we are told, apologize for me for that. and we are told that this is point 3 is to negative 3 is to 4 also, which means also this point will be now positive 3 is to 4, and this one we all know that it's 0 is to 0. Oh, my graph is turning here. Apologize me for that. My graph is turning here. So if they tell you to determine the inverse, the same applies also in this graph, that you must understand that this graph now, when we are now determining the inverse of this function, we determine it in this way, that now this is negative 3 is to 4, which means the inverse is 4 is to negative 4 is negative 3. This is our 4. Okay. No, this is our 3. This is our negative 3. This is our 4. So now we have 4 is to negative 4 is to negative 3. So now this point has been reflected along the line x is equal to 0, and now this is now the point, the new point of the inverse. Then now again this one will be reflected. It was 4 is to 3. Now it will be 3 is to 4. Where is 3? 3 is here. Where is 4? 4 is here. So we also have another point here. Now 0 was to 0, 0 is to 0. So now we are now plotting our graph. Do you see that? So this is our inverse functions. So now we have what is important, which we must take care and take note of, that how do you determine the inverse, or how to calculate, or how to find the inverse, algebraically. Algebraically. So how do we find the inverse of a function algebraically? So the steps are these ones. Please take note of this step. The step number 1, you replace f of x with y. So you see f of x and you are given f of x replaced with y. Then now step number 2, you swap x and y. Okay. Now the last step is easy. I think you can see that. Then you solve for y. So that's how you do, and that's how you determine the equation of the inverse of the function. Okay. So for example, so that you can get relevant to it. Example, the question will say determine, if the moment you see this f and negative 1, this is f inverse, the inverse function of f. It's f inverse of x in the form, maybe they'll say in the form y equal to in each of the following. I just want to do 3 examples for you. Okay. So my first example, I'll just say maybe f of x is equal to 5x minus 2. Maybe my first example is 5x minus 2. My first example is 5x minus 2. My first example is 5x minus 2. Okay, that is my first example. So how can we determine that? How can we determine the inverse function? How can we determine the inverse function? How can we determine the inverse function? So we say that the steps which we have is this one. You replace f of x with y. The step number 2, you swap x and y, then you solve x. So step number 1 says that replace f of x with y. So here is f of x. So now if they say replace f of x with y, now we have y is equal to 5x minus 2. Then that's our step number 1. Step number 2, they told that swap x and y. Where there is y, you put x, and where there is x, you put y. Then now we solve for y. So now we have x plus 2 is equal to 5y. You divide both sides by 5, divide both sides by 5. Then you end up having y is equal to 1 over 5 x plus 2 over 5. Or others, we will just simplify it further to an extent that is 1 over 5 and x plus 2. This is one and the same thing. And also others can say y is equal to x plus 2 divided by 5. This is all the same. Then therefore our f inverse in this instant, f inverse of x will be equivalent to x plus 2 divided by 5. Okay, so maybe let me just give you two examples. Maybe they'll give you an example again and tell you that f of x, no, let's just g of x is equal to x squared minus 2. So in this instance, how do you do it? So we know that the first step is we swap g of x by y. So where there's g of x, now we'll substitute by y. So we have y is equal to x squared minus 2. So what do we do now? Step number 2, we said we swap. So now we're gonna swap the value of x and the value of y. Then we're gonna have x is equal to y squared minus 2. Then now we solve for the value of y. So we make y the subject of the formulas. Now x plus 2 is equal to y squared. Then we square both sides, plus and minus. Then therefore what will be your y? Your y will be equivalent to plus or minus square root of x plus 2. So that will be therefore your inverse function, oh sorry, it was g, your g inverse will be plus or minus x plus 2. Now I want to talk about the domain of graphs and the range. I want to talk about the domain and the range of functions. I want us to talk about the domain and the range of the functions. Domain and the range of the inverse function. So, for instance, we are having the parabola, which is in this format, and it's the graph of f of x. Then we already know that the inverse, I'll just use something different. This is the axis of symmetry. Then now the inverse now will be like this. This is f inverse. I think I just showed you an example right now that this f inverse of x. So these are two graphs. So what I want you to always know that the domain, let's talk about the domain of f of x. This is the domain of f of x, and we are saying that x is the element of real numbers because it's not having any x values. So all the x values, it's because, check it out, so it is the element of all the real numbers from negative infinity to positive infinity. That's the domain, because the domain, we are looking at the x values of the function. Then now the range of the function of f of x, now we are now looking at the y values of the function. So on the y values, we are seeing that the graph is not found below y is equal to 0. So what do we do now? What is important is to be able to see that the range now, it's starting from 0, 0, 0, 0. So it's y is greater or equal to 0. So this is our range of the function. Now let's talk about the inverse function now. What is the domain? The domain of the inverse function of f inverse, when you say that the domain is the x values. Do you see something now? This is our inverse function, and the x values are starting from x greater or equal to 0. Do you see that now? So now we have our domain will be x is greater or equal to 0, and our range, will be our range of f inverse of x. And we know that our range of a function is always the y values. So let's check on the y values. These are the y values, and we can see that the graph is now on this line from negative infinity to positive infinity. So did you realize something on what happened right now on this scenario which I gave you? So now we can conclude that the domain of f of x is the range of the inverse function. It is the range of the inverse function. In this case, the inverse function f inverse of s, and also the range of the function, maybe f of x is the domain of the inverse function. It's the range of the inverse function. It is the range of the inverse function. Did you see that? That we had the domain x is equal to element of real numbers, and we say that the domain of f of x is equivalent to the range of the inverse, and we can also see that here. And we can also see that. Here. So that was a small overview which I had for you guys. Now let's do questions now. So now I took a question paper from May or June for June exam in 2017. That's for reference. In 2017, May in 2017. All right, amazing. Now, question 4. Guys, please assist me. I'll be checking on the comment section. As I'm seeing people are interacting with me. Please don't hesitate to type something or type your answer so that you can assist each other. All right. So now let's go and check on our question 4. Let's look at our question 4 now. Let's look at our question 4. Right. The sketch below shows the graph of f of x is equal to 6 minus 6 over x. F of x is equal to 6 over x minus 4 plus 3. The asymptotes of f intersects at A. So A is the intersection of both the vertical and the horizontal asymptote. So this is how you're analyzing your question. You are reading that you are given that, oh, the graph below shows the graph of f of x is equal to 6 over x minus 4 plus 3. The asymptotes of f intersects at A, which means A is a coordinate of the intersection of both the horizontal and the vertical asymptote, because a coordinate consists of the x and the y value. Then also they told us that the graph of f intersects the x-axis and the y-axis at C and B respectively, and we can see that at B it is the y-intercept and at C it is the x-intercept of the graph of f. Now question number 4.1. On my 4.1 they say write down the coordinates of A. On our statement they say that A is the point of intersection of the asymptote. So what do we do in this kind of equation? Now they want us to determine the coordinates of A. We know that A is the coordinates of the vertical and horizontal asymptote. Let's determine our vertical asymptote. The vertical asymptote in this case will be x is equal to 4. Is there anyone with that question on that question? And what is our y-intercept? Y is equal to the value of q, and this time the value of q is positive 3. Okay, in this case it's positive 3. So those are our x and y intercepts. So therefore the coordinate A is 4 is to 3. Someone will ask me, where is this 4 coming from? We say that on a this is a hyperbola. We can even see that a hyperbola has 2 asymptotes. So how do we determine the vertical asymptote? The vertical asymptote is the one which is x is equal to 4. Why? Because we took the denominator and said x minus 4 is equivalent to 0. Then we made x to be the subject of the formula. So that's when we end up having this 4 here. Then q is always the horizontal asymptote of our graph. So the coordinate A is 4 is to 3. Is there anyone with any question? Okay, if not, let's move on. Determine the coordinate, calculate the coordinates of B. Where is B? B, we said, and we were told that B is the y-intercept. So what does that mean if B is the y-intercept? We are on number 4.2. It means that B is a y-intercept, so it have 0 is to y, which means x is 0. So do you still remember that when you say that in order for us to determine the x-intercept, the y-intercept, you let y to y to be equal to 0, and when you want to determine the y-intercept, you let x to be 0. So this is also the case, and we can also see that the x value of coordinate b, it's 0, and the y value is the y-intercept of the function. So what do we do now? I've already I written it in a method which you can understand that b now it's 0 is to y, where your b is 0 and your y is what you are calculating, which is the y-intercept. So what do you do now? You substitute this coordinate in, substitute b 0 is to y in f of x. Okay, so we have y is equal to 6 over 0 minus 4 plus 3. Then we use our calculator. That will be y equal to 6 over negative 4 plus 3. Then using your calculator, you will get 3 over 2. So now we can conclude that the value of b 0 is to 3 over 2. 0 is to 3 over 2 is the value of coordinate b, which is the y-intercept. Now the next question is telling us that determine the coordinates of c. Where is c? C is the x-intercept of the function. So just like what we did initially, so how do we determine the x-intercept of the function? We know that on the x-intercept, we let y to be equivalent to 0. So also now we know that c is x is to 0. Then now we substitute c, which is x to 0, in a f of x. So that's how you just solve it. Is equal to 6 over x minus 4 plus 3. We transpose negative 3 is equal to 6 over x minus 4. Then we cross multiply. Then we have negative 3 times x minus 4 is equivalent to 6 times 1, because it's negative 3 over 1. Then we have negative 3x plus 12 is equal to 6. Then negative 3x is equal to 6 minus 12. And 6 minus 12 is negative 6. Okay, because we're going to transpose positive 12 to this side, then it's going to be negative 12. So it's going to be 6 minus 12. Then we have negative 6. Then you divide both sides by negative 3. Divide both sides by negative 3. Then now we end up having our x to be equal to positive 2. Then therefore the coordinate of c is 2 is to 0. So if you do in that order, you'll be able to understand what's really going on. All right. We are collecting marks, full marks. 4.4. Calculate the average gradient of f between b and c. How do we calculate the gradient? We know that according to the analytical geometry which we were taught in grade 11, we know that the gradient is represented by the small letter m, and it's always y2 minus y1 over x2 minus x1. So now we want the gradient of between b and c. We want the gradient between b and c. What is our b? Our b, we said it's 0 is to 3 over 2. What is our c? Our c, it's 2 is to 0. So this is x1 y1 x2 y2. All right. So in this case, we're gonna have what is our y2? Our y2 is 0 minus 3 over 2 divided by 2 minus 0. Then we use our calculator. Then we'll end up having negative 3 over 2 divided by 2. Then you use your calculator. Then we have negative 3 over 4. So this is our gradient. That's our gradient, guys. That's our gradient. You are just using the basic information which you were taught in grade 11. Please don't hesitate to ask any question if you have one. I'm willing to answer your question. Right. 4.5. Now let's check on 4.5. Now determine the equation of the line of symmetry of f which has a positive y-intercept. So which one has a positive y-intercept? Do you still remember when we said that the axis of symmetry of a hyperbola is just easy? It's either it has a negative x minus p plus q, or it's x plus it's x minus p minus q. So this one is it has a positive gradient, this one is a negative gradient, this one is a negative y-intercept, this one is a positive y-intercept. So how do we do in this instant? All right, so now they asked us to determine the line of symmetry of f which has a positive y-intercept. So we just do this in this manner, which has a positive y-intercept. So we're gonna have y is equal to negative x minus 4 plus 3. Okay, did you see something? I just took it as it is. This is my function. Let me just come back here. This is my function, which is this is my function. Just do this. Okay, this is my function. So we know that the axis of symmetry is always this. Okay, this is always our axis of symmetry. So it's either it's positive or we apply the negative sign on this part. So what do we do? So we just took it as it is here. Then we want to determine our axis of symmetry. So now the axis of symmetry, which has a positive y-intercept, will be negative. Negative times x is negative x. The negative times negative 4 is positive 4 plus 3. Then you end up having x is equal to y is equal to negative x plus 7. So this is our our equation of axis of symmetry. All right. We are moving. Don't be left behind. If you have any question, do ask if you have any question so that we can assist each other. All right. Now let's move forward. To question number 5, and it's our question number 5. We have question number 5 and question number 6. Question number 6 will be our last question of the day. So now let's now do our question number 5. Let's do our question number 5. Now, given f of x is equal to x squared minus 5x minus 14 and g of x is equal to 2x minus 14. On the same set of x's, sketch the graphs of f and g. Clearly indicate the intercepts with x's and turning point. So what we are given here, now we are analyzing the question together. We are told that this function is f of x is equivalent to x squared minus 5x minus 14. And when we are looking at that function, firstly, initially, f of x is equal to x squared minus 5x minus 14. We can see that this is a parabola. So what do we do now? Since we know that this is a parabola, we must be able to determine our x-intercept first. So let's determine our x-intercept. X-intercept, will let our y equal to 0. So it will be 0 is equal to x squared minus 5x plus minus 14. Then now we solve for x, and we know that you must just determine the points on x, and we can see that factors of x. Can someone help me to determine the factors of x? X 14, so we must have negative 7 plus 2 will give us negative 5. Yes, so therefore we know that it's going to be x minus 7 is equal to 0, or x plus 2 is equal to 0. So therefore x is equal to positive 7, or x is equal to negative 2. Then therefore in coordinate system, this is our x-intercept in coordinate system. It's the n1 and 10 equation. So in general, we just solved and we equated our function to be equivalent to 0. Then we solved for x. So we find that our x is negative 7. It's positive 7, and another one is negative 2. Then also now we must know the turning point on which your graph will turn, or will turn like this. Okay, so how do you determine that? We know that x is equal to negative b over 2a. What is our b? Our b is negative 5. So we're gonna have negative 5 over 2. And what is our a? Our a in this instant, our a it's 1, because it's just x squared. So we have 2a. So we end up having negative 5 over 2. We end up having negative 5 over 2. Yes, we end up having, no, sorry, it's negative 5. So we don't forget the sign, just like what I just did right now. Don't forget the sign. So it's negative times negative, that's positive 5 over 2, which is the same as 2,5 in decimal form. Then now we determine the value of C. How do we determine the value of Y, the Y coordinate of the turning point? Y is always equal to 4AC minus B squared divided by 4A. What is our A? It's 1. Our C, it's negative 14 minus B squared. Our B squared was negative 5 squared. All divided by 4 times 1. What is our 4 times negative 14? 14 times 4. That's 6 carry 1, 4. That's 56. So we have negative 56 minus 25 divided by 4. So negative 56 minus 25, it's just 81. So end up having 81 over 4. I used my head, but I always advise that you use your calculator. So I have 81 over 4, which is almost the same as 20 and a quarter. Okay, so the turning point, therefore TP, it's 2,5 and 20, oh sorry, it's negative, sorry, because negative 56 minus 25 is a negative, so it's negative 20, negative 20,25 in decimal forms. Okay, or you can write it in fractions. TP is just 5 over 2 is to negative 81 over 2. Then this is our function of f of x. Let's plot our function of f of x now. So we have 0, we have 2, 4, 6 till we reach 20. Okay, negative 20, then we have negative 22. So from 0 to, let me just do this. So from 0 we have our point, let's just I have 0. So we have negative 2, negative 4, negative 6, negative 8, negative 10. Then till we reach negative 20 and a quarter. And we also have, no, that will confuse you. Let's just continue with our 2, negative 12, negative 14, negative 16, negative 18, negative 20, negative 22. Okay, so the same applies also on the positive one from 0 to 22. Then on the x-axis we're only ending at 7, so we can have 1, 2, 3, 4, 5, 6 and 7. Then also have negative 1, negative 2, negative 3 until we reach negative 7. Okay, so we said that our x-intercept is positive 7 is to 0, and the other one is negative 2 is to 0. Then our y-intercept is 2,5. 2,5 is in between here, 2,5, and it's negative 20 and a quarter, or 20,25. So I'll just place it somewhere there. So this is our turning point. So we can be able to plot our function. Plot our function of f of x. Plot our function of f of x. Sorry for that. So this is our function of f of x. Then now we must plot the function of g of x, g of x. So we are given that g of x is equal to 2x minus 14. G of x is equal to 2x minus 14. So what do we do in that instant? So we know that again we must calculate the x-intercept, and our x-intercept, it's always we let our y to be equal to 0. So 0 is equal to 2x minus 14, then 2x is equal to 14, then x is equal to 7 as well. So we also have 7 is to 0 on the x-intercept. Then the y-intercept, so what happened here is we transposed negative 14 to this side, and now we ended up doing 2x is equal to 14. Then we solve for x by dividing both sides by 2, then we end up having x is equal to 7. Then we write 7 in the coordinate form, and this 2 is to 0. Okay, now we want to determine the y-intercept, and the y-intercept of a straight line is you just let x again to be equal to 0. So we have y is equal to 2 times 0 minus 14. So we end up having negative 14. So therefore, the coordinate here which we have, we'll now plot it now on the function, because this is negative 14. Oh, sorry, this is 0. 0 is to negative 14, right? So since it is 0 is to negative 14, that will be, we just come here again. This is 0. Where's negative 14? Here is my negative 14. Okay. Then we also have 7 is to 0, which is here. Let me just plot this in a different color so that we can be able to see 0 is to 14. And we also have 0 is to 7. So we join our two lines. We join our lines in peace. So this is the graph of g of x. So what we did here is that we started by determining the x-intercept and the y-intercept of the function. Then after we have done that, we determine the turning point of the function, since we realize that this function which we are given here is a parabola. Then the next thing which we did was that we were able to determine the x and the y-intercept of the straight line, which is g of x. Then we were able to plot our function. Is there anyone with an equation? Right. Since no one has a question, let's proceed and move on to the next question now. What is the next question? 5.2. Determine the equation of the tangent of f at x is equal to 2.5. 2.5. How do we determine the equation of the tangent to f at x is equal to 2.5? Do you realize this is easy? Why? Because we know that the x-intercept, we say that, we still remember when we were determining the axis of symmetry. 5.2. Let's use this black again. So at 5.2, initially we were able to determine the axis of symmetry. Where is it? So we determine the axis of symmetry, and we find that our x is equal to 2.5. 2.5 is the same as 5/2, ne? So 2.5 and 5/2 are the same thing. So now what are we asked to now? We are asked to determine the equation. So they just want you to write down the y value of that function. So basically now, since we already know and we have already calculated that x is equal to 2.5. So what is the y value? Our y is equal to negative 20.25. But in that instant we calculated and we get negative 81/4. So this is what the answer, or the answer which they are looking for. That's the only answer which they are looking for. Now the next question which we have here, on 5.2, they say determine the values of k for which f of x is equal to k. We will have two unequal positive real roots. Sorry for that. How do we do that? So we were given that f of x initially is equal to x squared minus 5x minus 14. So now we are saying that f of x must be equal to k. So k is now equal to x squared minus 5x minus 14, which is the same as x squared minus 5x minus 14 minus k is equal to 0. So now on this function, or on this, they want you to determine the values of k for which this will have two unequal positive roots. So how do we have unequal positive roots? We know that it's always the discriminant must less than 0. So now we look on our function. So we can see that in this portion is the portion which we are talking about. Okay, we didn't use this one. In this portion is the portion which we are talking about. We have negative 14 here, and we have this. So we are now saying that determine the values of k for which f of x will have two unequal positive real roots. So we can see that here it will have two unequal positive roots, the value of k, because here it will have a positive here, and here it will also have a positive, which is, but it's a positive unequal real roots, because we know that real roots are always square root of 2, square root of 4, square root of 16, you know, perfect squares. But unreal roots are those ones which will give us commas. So now we can see that the value of k must be between 5.3. So we can see that the value of k must be between negative 81/4, which is the y value of the turning point, must be less than the value of k and must be less than negative 14. So we are seeing that we can actually see that the k value must be between the y-intercept of the turning point, and it must be between the y value of the y value of the turning point, as well as the y value of the y-intercept of the function of g of x. So that will enable us to see that the value of k, which will have two unequal positive real roots, will be there. So in other words, you must be able to analyze your function. You must be able to analyze your graph which you are given in the question. All right. So that will be our answer. That will be our answer. Then now let's move on to the last question, 5.4. 5.4. Okay, so on 5.4, a new graph H is obtained by first reflecting G. Which one is G? Oh, we are given that G of X. We are given that G of X is equal to 2x minus 14. So now the question is saying that a new graph H is obtained by reflecting G in the x-axis. So when the graph is reflected along the x-axis, the whole graph will change. And then it is translated in it was translated 7 units to the left. Write down the equation of H in the form of H of X is equal to mx plus c. So how do we do that, guys? So like first, we know that when the graph reflection in the x-axis, so we know that when our graph is reflected on the x-axis, it is now having negative 2x minus 14. All right, because the negative sign is showing that the graph has been reflected along the x-axis. So when it has been reflected along the x-axis, the whole graph will change. So now we multiply it by a negative. The whole graph must be multiplied by -1. So now we remove the negative sign and remove the bracket. You have negative 2x, sorry. We multiply the graph by the negative sign. We have negative 2x plus 14. So this is now the reflected graph. Now they are saying that the graph has been shifted. It has been shifted 7 units to the left. So when you are going to the left, we subtract, we add. Sorry, when we are going to the left, we add. So what do we do now? We come here, we add on the x value. So we have negative 2x plus 7 plus 14. So this is a new function of h which has been reflected along the x-axis and has been shifted 7 units to the left. So first things first, we started by answering the question of the reflection in the x-axis. So we multiplied the whole graph by the -1 because the whole graphs have changed. Now we come now and we look at the shifted 7 units to the left. So when your graph is shifted horizontally on x or to the left or to the right, it only affects the x. But when it has been shifted up and down, it will affect the y value. So if it was shifted 7 units upwards, it was going to affect the positive 14. So we're going to say 14 plus 7. It was affected 7 units downwards. It was 7 minus 14. But in this case, they say that shift 7 units to the left. So when you are moving to the left, we are seeing we add. So now we finally have negative 2x minus 14 plus 14. We know that negative 14 plus 14 is 0. So we have now y equal to negative 2x. So now we conclude that our function, the new function h of x, will be negative 2x. That will be our new function of h of x, which will be formed in this formatting. Is there anyone with any question? Now we are doing the last question of the day. Now we are doing and we are looking at the last question of the day. So now let's look at the last question of the day. Let's look at the last question of the day. All right. So on the last question of the day, we are given it's question number 6, right? Please be careful and be attentive in this question. They're saying in this case below, P is the y-intercept. So we are also told that P is the y-intercept of the graph f of x, is equal to bx. T, where is T? P is the reflection, or P is the y-intercept of the graph f of x. So we already know that P is 0 is to y. So that's how you analyze the question. As you are reading, you are analyzing at the same time, okay? So you read, you analyze, you read, you analyze, you read, you write down and analyze, okay? Then now they say that in the sketch below, P is the y-intercept of the graph of f of x is equal to bx. So since it is the y-intercept, which means the x value is equal to 0, and now we have to determine the y value. Now also at the same note, T is the x-intercept of the graph of G. Where is T? T is the x-intercept of the graph of G. So we are also told that T is the x-intercept of the graph G, the inverse of f. So G of x is the inverse of f of x, and it also have the point T, which is the x-intercept of the graph of G. So you are analyzing our question. Then also say that the straight lines are drawn through A and R and through P and T. So there are two straight lines which are drawn, the straight line from PT and also the other one OR. Now the question number 1, determine the equation of G in terms of B in the form of Y. So now they want us to determine the graph of G, the equation of G. So we were told, and when we were analyzing our question, we saw that the graph of G is the inverse function of f of x. So now we must determine the equation of the formula of graph of G of x. So that's easy because we're given f of x is equal to b of x. So we say the first thing, we write f of x in the terms of y. Then now we swap x and y. Then we have x is equal to b y. Now we have to solve for y. So how do we solve for y? We have what we call the logarithms. So we apply the log, then we have y, then we will have log of b times x is equal to y, because we'll just drop it down here as and it will become the base, and we conclude it. So therefore f inverse of x is equal to log b of x. And we know that f inverse, you still remember when I was writing what we have here, we know that f inverse is the same as the equation of g of x. So since this is the equation of g of x, also we can conclude that g of x is equal to f inverse of x, and g of x is equal to log b times x. Okay. Now write down the equation of the line passing through OR. Write down the equation of the line passing through OR. Write down the equation of the line passing through OR. We can see that line OR is the reflection of the graphs. It's the line of symmetry which is showing the reflection of both graphs. So that's easy because y is always equal to x in this kind of instance, because we are seeing that the values y is equal to x on the point of R. You can just check also R. R is the intersection of both the inverse, the graph of f and its inverse. So we can say that the equation of OR, it's y is equal to x. Now since y is equal to x, write down the coordinates of p. Where is p? Right, where is p? So that will be easy for us to write the coordinates of x, because now we are given that y is equal to bx, and we say that p is the where is our given information which we wrote down. We say that p is 0 is to y, so we can be able to determine the y value, and we substitute point p, which is 0 is to y. So it will be y is equal to b to the power of 0. Then we end up having y is equal to 1, because anything to the power of 0 is equivalent to 1. So therefore the coordinate of p will be 0 is to y. Is there anyone with any question? Is there anyone with any question? Is there anyone with any question? Okay, since no one has any question, now let's move on to the next question. So the most question saying that 6.4, they are saying that write down the determine the equation of the line passing through PT. P, we already know the coordinates of P, which is raised to 1. Now they ask us to determine what is the coordinates of T though. I always love for us to know the equations of T. So we say that f of x has an inverse, which is g. So you still remember when I was explaining that if we are given this function, for instance, this is the function, and we are given this point is 1 is to 0, and we have its reflection, the reflection of this point, or the inverse of this function will be 0 is to 1. So we just swap this, and we can see our t in this instance, that t is a point on the inverse function of f. So basically, since we know the point p is 1 is to 0, so automatically now we know that the inverse point, which is t, will be 0 is to our point p here it's 0 is to 1, so t it will be 1 is to 0. So now they are saying determine the equation of the line passing through. So we must know our gradient, and we know the point p it's 0 is to 1, and point t it's 1 is to 0. So we determine our gradient, and we know the gradient is y2 minus y1 over x2 minus x1. And what is our y2? It's 0 minus 1, and our x2 it's 1 minus 0. Then we end up having the gradient, which is the same as -1. Now let's determine the equation. We know that in order for us to determine the equation, we can use the formula y minus y1 is equal to m is equivalent to m x minus x1. Then we substitute any value. We can substitute p or coordinate t. So I want to substitute the coordinate of t. I want to substitute the coordinate of t. The coordinate of t in this case is 1 is to 0. So where it's y, we put 0, then -1 is our gradient, and x minus 1. Then y will be equal to -x plus 1. So basically, this is our equation of the graph. This is our equation of the graph, which is, then now they say calculate the value of b. Calculate the value of b. How do you calculate the value of b? How do you calculate the value of b? So in order for us to calculate the value of b, we can see that at point R, we can also see that PT and OR intersect. I'm writing so that you can see and see on the question which we have. Sorry for that. Yes. So we can see that at point R, it's the intersection of both the line OR and the line PT. And now we know the equation of line PT. So what was the equation of line PT? It was y is equal to negative x plus 1. And we also know the equation of OR, which was y is equivalent to x. So y and y, they are the same. So we end up having x is equal to okay, let me just do this, solving it simultaneously. This is equation 2, this is our equation 1. So equation 1 will be equivalent to equation number 2. So we have -x plus 7 is equal to x. Then we have -x minus x is equal to -7. Then -2x will be equal to -7. Okay, I don't know if I did, oh sorry, it's not 7, it's 1. A mistake. I don't know why I'm doing this silly mistakes. Okay, it's 1. So since we said that our equation was x negative x plus 1, so this is the one which we have here. So we're going to have negative x plus 1 is equal to x, then we transpose x to this side, then we have x negative x minus x, then transpose positive 1 to the other side, then it will be negative 1. The negative 2x is equal to negative 1, then we divide both sides by negative 2, then we end up having the x to be equivalent to 1 over 2, which is half. So what is our y value? So we can now determine the y value by saying y is equal to 1 over 2, because now we can, let me just do this. Let me just say substitute x is equal to 1 over 2 in equation, let's substitute in this equation 2, okay, in equation 2. So y, where there's x now, we must put 1 over 2. So this is the coordinate form. Then now we know that f of x was initially given that it's b is to x, and we know that it is the same as b to the power of x. So what do we have now? We know that we have a point 1 over 2 is to 1 over 2. So let's substitute so that you can determine the value of b. So 1 over 2 is equal to b to the 1 over, same as 1 over 2. Then after that we can now solve. Okay, after that we can now be able to solve our equation. So how do we do that? According to the laws of exponents, we can just say 1 over 2, and b is 1 over 2 times 2 over 1. We do what we do here, we do both sides. Okay, then therefore b is 1 over 2 squared, it's the same as 1 over 4. So the value of b is 1 over 4. That is my 1.5, and it's 5 marks. Wow, and it's 5 marks. Thank you so much, guys. That was what I had for you for today. I hope each and every one of you were able to enjoy to the best to this session which we had. Please, if you have more questions, please don't hesitate to ask your question. You can ask even on Facebook. We'll be able to respond. On Facebook, it's also Yebo Tutor. You can also ask on the comment section. We'll be able to respond and assist you also in the process. Thank you so much. Stay blessed and have a good evening.